Okay, this is worksheets 5-5.4, I think it is, a system of equations. So I'm going to be running through some of these problems just so you can see them done and see me talk about them. And we'll go from here. Okay. So first of all, you have three different options. You can use graphing technique, elimination technique, or substitution technique. I don't use the graphing that much just because, as I've said in class, it's not a very accurate way to do it, because if the solutions aren't integers, then it's hard to see the solution accurately. So I'm generally going to use an algebraic technique. So and I think it depends on how the problem looks. I may use substitution sometimes, may use elimination other times. So in this case, I noticed that it's pretty easy to get x by itself in that first equation. So I'd start out by going 6 plus y is equal to x. That means that way I can substitute 6 plus y in for x. So then I take the other equation, and here it is right here, plus 5/3 times x equals 0. And of course, I'm taking the x out and putting in a 6 plus y. Okay, so far so good. That's the substitution method. And then I see fractions there, so generally when I see fractions I want to eliminate them, but the key here is now I have an equation with nothing but y's in it. So I'd probably multiply the entire equation by 3. That would give me a negative 3y minus 18 plus 5 times 6 plus y is equal to 0. Distribute the 5 through and I get negative 3y minus 18 plus 30 plus 5y equals 0. And then we'll combine like terms and get stuff on the other side. So the negative 3y and the 5y, that would be 2y. And negative 18 and 30 would be 12. I'll move that to the other side, so that'd be negative 12. Divide both sides by 2 and I get y equals negative 6. Then I go back up to this equation, and it looks like if y is negative 6, that means x has to be 0, doesn't it? So my two solutions would be y equals negative 6 and x equals 0. Okay, moving right along to this one. In this case, once again, it's pretty easy to get x by itself, only this time on the bottom equation. So I divide both sides of that equation by 2, and I would get x equals negative y plus 6. And so then I'm going to replace x with negative 6, or negative y plus 6, with this equation. So this equation comes down here, and I get 3 is equal to, so negative y plus 6, that takes the place of the x, plus 2/5 y. And again, since I have variable or fractions in my equation, I'm going to multiply everything by 5 to get rid of them. So that would be 15 is equal to negative 5y plus 30 plus 2y. Combine like terms and move the 30 to the other side at the same time, so that'd be a negative 15 over here, and negative 5y and 2y would be negative 3y. So then I divide both sides by negative 3, and I get 5 is equal to y. And then I run up here again, and therefore x has got to be equal to negative 5 plus 6, which would mean x is equal to 1. So that would be my two answers. Okay, we're cruising now. So here's another one that probably is substitution. It'd be easy to get the y by itself, although you could do elimination here. If I move the 5 over here, so notice I could change this equation to let's see, negative y plus 5x minus 5 is equal to 0. So now they're lined up nicely. So if I multiply this new equation that I built by negative 2, then I would have a negative 2y plus 8x minus 6 equals 0. So this guy would just write down here. And if I multiply this thing, both sides by 2, I get, or negative 2 I mean, I would get positive 2y. And negative 2 times 5 would be negative 10x. And negative 2 times negative 5 would be positive 10 equals 0. So then if I add the two equations together, the negative 2y and the 2y equals 0. 8x plus negative 10x is negative 2x. And negative 6 plus 10 is 4 equal to 0. So notice I did exactly what I wanted to do. I wanted to get rid of one of the variables by adding the two equations together. So then I'd subtract 4 from both sides, and I get negative 2x is equal to negative 4, which means x is equal to 2. Okay, and then we just got to go back and find y, so I'd probably grab this equation right here just because it's sitting out there. And that would be negative y plus 10 minus 5 is equal to 0, plus 10 because 5 times 2 is 10. That means that negative y plus 5 is equal to 0, which means y is 5, right? Because this would be negative y is equal to negative 5, which means y is equal to 5. Okay. Moving right along here. Once again, we could move the 13 over and line these up. So I would have 6y minus x plus 13 equals 0. And then this, I would have a y plus x plus 1 equals 0. So I'm just getting them all lined up. And then I notice that, oh, when I do that, I notice that the x's are exact opposite of each other. Perfect. So when I can just add them together, that would give me 7y, and negative x and x is 0, and 13 plus 1 is 14, a positive 14. So then I move the 14 to the other side, and I get 7y is equal to negative 14, which means y is equal to negative 2. And if y is equal to negative 2, that means that I can plug it in right here. Give me 0 is equal to x minus 1. Add 1 to both sides, and I get 1 is equal to x. Okay. Moving along here. Here's another one that, again, if I just move everything to the same side, it would probably work out good. So I'm going to rewrite both equations. So that would be 0 is equal to 8y minus 5x minus 18. And then down here, 0 is equal to, I'm just going to line them up so I can see them. That'd be negative 4y minus 6x minus 8. And I look at that, and right now nothing's going to cancel out nicely. But if I multiply the bottom by 2, then something will happen nicely. That would give me 0 is equal to negative 8y minus 12x minus 16. So then I'm going to scratch that one out and use this one and add them together. So that'd be 0 equals 8y, and negative 8y is 0. Negative 5x and negative 12x would be negative 17x. And negative 18 and negative 16, that would be negative 34. Negative 34. So if we bring this up here, let's see, that'd be 34 is equal to, I might as well move the 17 over. That'd be 17x is equal to negative 34. That means x is equal to negative 2. And then I got to plug back into one of these equations, like for example, I can go back to this first one right here. That would be negative 8y is equal to 10 minus 18, which means negative 8y is equal to negative 8. So y is equal to 1. Alrighty, moving along here. I think I just moved the 9x over, so I'm going to have an, let's see, negative 9x plus 18y is equal to negative 36. because I just added -9 to both sides, right? And then this one here is going to be 9x minus 2y is equal to 4. And look at that. They worked out nicely. Just add them together. -9x and 9x is 0. 18y and -2y is 16y. And -36 and 4 would be a -32. So then y is equal to -2. And if y is equal to -2, that means that, let's see, I'll grab this one. Plug in -2 in for y, so that'd be -36 is equal to -36 plus 9x. Oh, interesting. So if I add 36 to both sides, I get 0 is equal to 9x, which means 0 is equal to x. Nice. Okay. Moving along here fairly nicely. This is already set up pretty good. They're just on opposite sides, so I'll just put them on the same side. So that'd be 2x plus 4y is equal to 18, and -12x minus 6y is equal to -36. Let's see, what do I want to do? Probably multiply the top equation by 6 so I can eliminate the x's. So that'd be 12x plus 4y. No, Thad. 12x plus 24y is equal to 6 times 18, that'd be 108. So I'm not going to use that one anymore. I'm using this one now. So then I add them together and I get 0 here, and I get, 18y there. And 108 minus 36, that would be 72. So, whoops, what happened here? So I'm experiencing some technical difficulties. Seem to have lost the worksheet I was working on. It just shut down, so I'm going to go ahead and end the video for right now, and then I'll try to pick up where I left off later. Okay, found it. Not sure what happened there. So here we go. 18 will go into 72. So 18 going to 72 4 times. So that would be my y equals. Then we have to plug into one of these babies up here. So maybe 2x plus 4 times 4 is equal to 18. So that'd be 2x is equal to, that's 16. If I subtract 16 from both sides, I get 2 there. X is equal to 1. Awesome. So on this one here, it looks like I've got 2y and a -y. That's pretty close to what I want. So I just will multiply the top one by 2, and that'll match them up. So if I multiply the top one by 2, that would be 4x is equal to -6 minus 2y. And the bottom one, I'm going to move the 4x over. So subtract 4x from both sides, that'd be -4x. Move the 6 over, that'd be +6. And leave the 2y alone. And when I add them together, oh wow, something weird happens. 4x plus -4x is 0. -6 plus 6 is 0. And -2y plus 2y is 0. So I end up with 0 equals 0, which is always true. Which means there is a infinite number of solutions. Which means these are essentially the same line. Okay. All right. Here we go over here. 3x minus 6y equals 9. -2 equals 6x minus 2y. Well, 6 is 3 times as big as 2. So that's probably what I'm going to do is multiply this bottom one by 3. And we'll flip it around. So I'm going to have 3x minus 6y equals 9. That's the top equation. Then if I flip the bottom equation around and multiply by 3, that would be 6x minus 6y is equal to negative 6. Add them together and I get 9x on this side because, oh, wait a minute. Whoops. Add them together and I get negative 12y, don't I? So I don't want to do that. So I should have multiplied everything by negative 3, not just 3. So negative 3 times 2x is negative 6x. Negative 3 times negative 2y would be positive 6y. And negative 3 times negative 2 is 6. So then I add them together and I get negative 3x. That's 0. And 6 plus 9, of course, is 15. So I get x is equal to negative 5. Then I go ahead and plug in x for negative 5. In one of these equations, I'll pick the bottom one. So that'd be negative 2 is equal to negative 10 minus 2y. And I add 10 to both sides, and I get 8 is equal to negative 2y. Divide both sides by negative 2, and I get negative 4 is equal to y. Okay, let's do another one here. Let's see. I think I would so none of these are going to be very nice, cooperate very nicely, right? I got a 5 and a 3 and then a 5 and a 6, although they are at least negative. So I think what I'll have to do is I'll get rid of the y by multiplying I'll have to multiply the top one by 3, so that'd be 15y plus 15x is equal to 0. And then I'll multiply the bottom one by 5. And that would be negative 15y, and flip it around, minus 30x, minus 45 is equal to 0. So I multiply the top by 3 and the bottom by 5. And so then I can add them together and I get 15y and negative 55 is 0. 15x and negative 30 is negative 15x. And negative 45 and nothing is negative 45. And of course 0 and 0 is 0. So I'll move 45 to the other side and I get negative 15x is equal to 45. Divide by negative 15 and I get x is equal to negative 3. And go back over here and let's see if 5y minus 15 equals 0. If I plug negative 3 in right there. So that would be 5y is equal to positive 15, which means y is equal to 3. Awesome. We're moving now. Okay, this video is getting long. I think I'll pause it and do a few of these without commentary. So there's number 11 and number 12. You can take a look at those and see if they make sense to you. And then number 13 and 14, I ran into some substitution ones that really lend themselves to substitution, so I thought I'd turn the video back on and make sure I run through these with you. So this, again, 15 is a good one for substitution because it has y by itself. So I'm going to take what this says, what the first equation says y is, and replace it for y in the other equation. So this equation, the bottom equation, becomes 3x minus 7 times 7x minus 23 is equal to negative 23. So you can see this equation is just like that one, except for the y has been replaced by 7x minus 23. So then we just solve this, or this equation. This would be negative 49x plus 163, I mean, is equal to negative 23. So then we add 3x and negative 49, that would be negative 46x, and subtract 163 from both sides, and we get negative 186. And let's see, will 46 go in there? What, maybe 3 times? That'd be 120 plus, nope, maybe 4 times. That'd be 160 plus 24. Oh, very close. Huh. I wonder if I did something wrong. 7 times 23 is... Oh, whoops, that would be 21, wouldn't it? Yeah, 2 times 7 is 40. 2 times 7 is 4. I mean, 20 times 7 is 140. Plus 21 is 161. Yeah. So this would be actually negative 184. And I think that'll go in there 4 times. So x is equal to 4. So then we go back up to here, the y equals, and we go y is equal to 7 times 4 is 28 minus 23, which means y is equal to 5. Okay, here's another substitution one right here, number 16. I'm going to substitute from the bottom one into the top, so that would be negative 6x plus 5 times negative 5x minus 10 is equal to 12. And let's see, that's going to be negative 6x minus 25x plus, nope, minus 50 equals 12. So negative 6x and negative 25x is negative 31x. And if I add 50 to both sides, I get 62. Therefore, x is equal to negative 2. And if I plug it in up here, that'd be y is equal to negative 2 times negative 5 is 10. Minus 10, oh, that'd be 0. So I get y equals 0. Okay. One more of these where I've got negative 6x minus 3 times negative 5x plus 14 is equal to negative 24. Negative 6x plus 15x minus 42 is equal to negative 24. Just distribute the negative 3 through. Combine like terms, and we get 9x is equal to, I'll add the 42 to both sides, and I get, what, 18. Therefore, x is equal to 2. Go back up here, y is equal to 2 times negative 5 is negative 10 plus 14. Therefore, y is equal to 4. This one's kind of a cool one. It's already, they're both y's are set equal. I mean, they both have y equals everything else, so that means that I could still do the same thing. I could just replace this guy in there for y. So I end up with negative 3x minus 6 is equal to negative 8x minus 11. Add 8x to both sides and I get 5x. Add 6 to both sides and I get negative 5. Therefore, x is equal to, I said negative 5. X is equal to negative 1. And then that means y would be equal to 8 minus 11. So y is equal to negative 3. Okay, this one's an interesting one, number 19. They actually already solved y for you. So they're telling you that y is equal to 7. So all I have to do is plug that in for y in this equation. So that would mean that 7 is equal to negative 6x minus 17. So if I add 17 to both sides, I get 24 is equal to negative 6x, which means x is equal to negative 4. So my answers would be x equals negative 4 and y equals 7. And finally, last but not least, we got the y's on both by themselves, so we'll just substitute one for the other. This will go into right there. So we have negative 3x minus 19 is equal to 2x plus 1. Add 3x to both sides and negative 1 to both sides. That'd be negative 20 is equal to 5x. Divide both sides by 5. I get negative 4 is equal to x. And then find out what y is. Y is equal to negative 8 plus 1 because I plug in negative 4 for x. Therefore, y is equal to negative 7. And that is the entire worksheet.